Hi again to everybody. So for today, we will be having our video lecture number 6. And our lesson for today is on arguments. So please turn your modules to page 7. Page 7 of your modules. And we'll start with the discussion in the last portion of page 7. And you will find there the definition of an argument. And according to the notes there, what is an argument? An argument is simply a collection of propositions. So we have already defined what a proposition is. It's a declarative statement that can either be true or false, but not both. So an argument is a collection of propositions where it is claimed that one of the propositions, which is called the conclusion, follows from other propositions called the premises. Okay, so basically an argument is just composed of two parts. We have the premises, which can be composed of several propositions, and the second part, which is the conclusion, but definitely the conclusion is just a single proposition. So an argument will have two parts, the premises and then the conclusion. And then there are two types of arguments. You have your inductive and the deductive. What's the difference? Let's read the definition of each. So for the inductive argument, one, where it is claimed that within a certain probability of error, the conclusion follows the premises. While for the deductive argument, one where it is claimed that the conclusion absolutely follows the premises. So you will find there that at first reading, the two arguments seem to be similar, okay? Since the conclusion can be derived from the premises. But if you will look closely for the difference, for the inductive argument, it is mentioned there that it is claimed that within a certain probability of error, the conclusion follows the premise. Okay? So it means that the conclusion may happen not solely dependent on the premises. Okay? So, for example, what's an example of an inductive argument? So let's say you are planning to visit your relatives abroad and you will be traveling by plane. But you are afraid of traveling by plane. And then, your relative will say, in going to our place, you may die because of plane crash. Okay? Because your relative knows that you're afraid of traveling using plane. Okay, so the conclusion there is, you may die. Okay, you may die. But the conclusion does not necessarily mean that you will die because of the plane crash. Right? So, your relative will say, yes, you may die through the plane crash, but there are also people that die by other accidents. Let's say, sleeping in a bathtub, nadulas sa bathtub. Okay? So, what we are saying here is that the conclusion is not necessarily directly obtained from the premises. Okay? So, you may die not because of the plane crash, but you may also die because of the plane crash. Okay? But for the deductive argument, one where it is claimed that the conclusion absolutely follows from the premises. Okay, so the derived conclusion will definitely be obtained from the premises. For example, all bananas are apples. All bananas are apples. A papaya is... All bananas are apples, right? All bananas are apples. A papaya is a banana. Therefore, a papaya is an apple. Did you get that? All all bananas are apples. All bananas are apples. A papaya is an what's that? All bananas are apples. Papaya is all bananas. What's the first statement again? All bananas are apples. Papaya is an apple. Therefore, a papaya is a banana. Right? So all bananas are apples. All bananas are apples. Or okay, better still, let me change the statement. It should be all bananas are apples. A papaya is a banana. Therefore, a papaya is an apple. So that's an example of a deductive argument. So definitely, the conclusion is obtained from your given premises. And we will be looking at what we call a valid argument. And what is a valid argument? A valid argument is a deductive argument. So what's again a deductive argument? The conclusion definitely comes from our premises. So it's a deductive argument that is said to be valid if whenever the premises are all true and the conclusion is also true. Okay? So remember that. An argument is valid if all the premises are true and that the conclusion is also true. Okay? And under this, we will be looking at the rules of inference. In our last discussion, we have considered our rules of replacement. So this time, we have another set of rules, and we call these rules as the rules of inference. And we have the first one. The first rule is what we call the rule of addition. And in this, we have the premise is P, and then the conclusion is P or Q. So again, an argument will be composed of two parts. You have the premise, and then you have your conclusion. There can be several premises given, but there is a single conclusion given. A valid argument is when all our premises are true and the conclusion is true. So for today, I would like to explain why those rules of inference are valid arguments. So in this case, we have two propositions, P and Q, and then we have the conclusion is P or Q. So according to the definition of a valid argument, an argument will be valid if the premises are true and the conclusion is also true. Therefore, in here, we have no choice but to use the value of P to be true because, according to the definition, the argument is valid if the premise is true. So P must be true so that this argument must be true. But we don't stop there. The conclusion must also be true. So it means if P is true, then Q can either be true or false. Right? We can have Q to be true or false. Now, from the conclusion, this is our connective OR. And we know that from the previous lesson, if we are using the connective OR, if one proposition is true, then this entire proposition must be true. Since P is already true, regardless of the value of Q, this will always be true. Okay? So whether Q is true, P or Q will still be true because P is always true. So if Q is false, still P or Q will be true. So, clearly, the first rule is a valid argument. Okay? So, an example here is, let's say, your friend will again tell you, oh, I now have a new boyfriend. And definitely my boyfriend is intelligent. Okay? My boyfriend is definitely intelligent. So, since you did not yet see the boyfriend, then you may conclude, oh, therefore your boyfriend is intelligent or he's also handsome. Since your Q may be true or false. Diba? So, kung nakita nyo na yung boyfriend niya is handsome, then okay lang. P or Q will still be true. Or, nakita ba yung boyfriend niya, hindi naman siya ganun kagwapo, but still, the conclusion will be true because totoo na matalino yung boyfriend niya. Diba? So, that's the first. The second rule that we have there is the conjunction. The second rule is conjunction. And under the conjunction, we have P, Q, therefore P and Q. So here we have two premises. Let's call this as premise A, and then we call this as premise B. And then we have our conclusion P and Q. So let's show that again this is a valid argument. Let's explain that it's a valid argument. We have two propositions. For this argument to be valid, the premises must be true. So if the premises must be true, then we have no other choice but to set P and Q to be true. So if P cannot be false, because if P become false, the argument will now be invalid. It will not be valid because P is not true. So similarly, Q cannot be false because if Q will be false, then it's no longer a valid argument. Therefore, if P is true, Q is true, go to the conclusion, P and Q. We have the conjunction. For the conjunction to be true, each proposition must be true. P is true, Q is true, therefore this is true. Then this is a valid argument. Okay? So that's your conjunction. Then the fourth one, or the third one, is simplification. 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 Sorry, it's so hard to write on the screen. Simplification. We have P and Q, therefore P. So we only have one premise, P and Q. And then we have one conclusion. Oh, of course, conclusion will always be a single one. And the conclusion is P. So according to the definition again, for our argument to be valid, each premise must be true. But since we only have a single premise here, this premise must be true. Since our premise uses a conjunction, for this to be true, P and Q must be true. Right? For P and Q to be true, P must be true, Q must be true. And since we now have P and Q is true, this will be true if and only if P is true. Therefore, it's a valid argument. P and Q, therefore P. So if you would like to rewrite this, you can also have this as P and Q, therefore Q. Same reasoning will be used there. That's the third. And then we have the fourth rule. Fourth rule is called the modus ponens. And under modus ponens, we have P implies Q as one premise. A second premise is P, therefore Q. So how to show that this is a valid argument? We have P, Q, and then P implies Q. So remember, we are just sticking to the definition. An argument is a valid argument if all the premises are true and then the conclusion is also true. Now, since each premise must be true, let's start here. For this premise to be true, so definitely P must be true. Okay? P must be true. And then, since P must be true, for the first premise to be true, since this is an implication or a conditional statement, P is true. For P implies Q to be true, then Q must be true also. Okay? So, we have P implies Q is true, P is true, and this will only happen if Q is also true. So, it is a valid argument. That's the fourth one, modus ponens. And then the next one is modus tollens. In some books, the spelling of tollens uses two L's. But in some books, they use a single L. But anyway, we're just using the name modus tollens. And the argument now is P implies Q, not Q, therefore not P. That's the argument. Let's show that our argument is a valid argument. We have two propositions only, P, Q, P implies Q. Okay. Going back to the definition, for this argument to be valid, the premises must be true, the conclusion must be true. Okay, not Q. For not Q to be true, then we have no choice but Q must be false. If Q is false, not Q will be true. Okay. If not Q is true, Q must be false. Q is false. We will use that. Q is false. P implies Q must be true. Since Q is false, P must be false. Because, go back here. If Q is false, P cannot be true. Because if P is true, true implies false will be false. Okay? But we want P implies Q to be true. Therefore, for this to be true, P must be false also. So, P implies Q is true. So, go back now to your truth values. P implies Q is true, not Q is true, not P is also true because P gets the value 0. Not P will be true. Therefore, it's a valid argument. Number 6. Number 6 is what we call our disjunctive syllogism. Disjunctive syllogism. And the disjunctive syllogism states that P or Q, not P, therefore Q. That's our argument. P or Q. We are now in page 9. P or Q, not P, therefore Q. Let's show again that this is a valid argument. And how do we show that this is a valid argument? Not P. This must be true, not P. For not P to be true, P must be false. Not P to be true, P must be false. P or Q must be true. but P is already false. For this proposition to be true, then Q must be true. Because P is already false, for this to be true, then Q must be true. Okay? So go over there. Again, you have P will be 0 so that not P will be true. And then for P or Q to be true, since P is already false, then we have no other choice but to use Q to be true. Therefore, P or Q is true. And then Q is also true. Therefore, this is a valid argument. Next, we have the hypothetical syllogism. Hypothetical syllogism. And this is now number 7. P implies Q, Q implies R, therefore P implies R. Okay. We have P, Q, and R. We have P implies Q, Q implies R, and P implies R. There you go. So we want to show that this is a valid argument. And for this valid argument, we have to show that it is possible that all the premises will be true and then the conclusion is true. Okay, for the first premise to be true, we want this to be true. And for P implies Q to be true, a conditional statement, di ba sabi natin nun, if the first proposition is false, regardless of the value of the second proposition, the entire proposition P implies Q will be true. Right? If P is false, automatically P implies Q is true. So there is a way to make P implies Q to be true. Okay. So we're done with that. Next. But we have two possible values for Q. Now, if we want Q implies R to be true, we can use Q to be false. So, let's choose Q to be false. So, if Q is false, automatically, Q implies R will be true. And then, remember, if we're using P is false, we're using Q is false, so that P implies Q, Q implies R are both true. And go to the conclusion, we're using P is false, so regardless if R is true or false, then P implies R will be true because P is false. Okay? Therefore, it's a valid argument. So, when is this argument valid? P is 0 or false, Q is false, then your R can either be true or false, regardless if the value of R is true or false. Okay? So, it's a valid argument. Next, number 8. We're almost done with our arguments. We have our constructive dilemma. And what do we have for the constructive dilemma? P implies Q and R implies S. P or R, therefore Q or S. So we have 4 we have 4 arguments or propositions P, Q, R, S. We need P implies Q and R implies S. And then we have P or R and then Q or S. That's the conclusion. Again, we want to show that this is a valid argument. Okay. Let's go over the values. This is a conjunction. Therefore, if we want this entire proposition to be true, remember, that's a premise. We want this premise to be true. So for this to be true, since this is a conjunction, P implies Q must be true and R implies S must be true. Again, we want the entire proposition to be true since this is a conjunction. P implies Q, R implies S must be true. And for P implies Q to be true, if P is 0, automatically P implies Q is true. So if P is 0, regardless of the value of Q, P implies Q will be true. So similarly, R implies S must be true. So if R is false, regardless of the value of S, R implies S will be true. Okay, so far, if we stick with P is false, R is false, then this entire proposition is true. So we're done with this premise. We are sure that this premise is true when P is false, R is false. Okay. Next, P or R must be true. P or R must be true. Okay. We are setting earlier P is 0, R is 0, so that this will be true. But if both P and R will be false, this entire proposition P or R will be false, because false or false will be false. So we will have a problem in the second proposition. P and R will be false. Okay. So what will be the remedy to make this proposition to be true? So for this proposition to be true, we can change one value for P or R. So let's say I would now change my R to 1. So if R is 1, so remember, we need to have R implies S still to be true. For R implies S to be true, we will not use, let's say, R to be 0. So because if R is 0, then P or R will be false, because we're sticking with P is 0. But if I now change R to be true, for R implies S to be true, then I only have one choice for S. S must be true. Right? Okay. If R is true, S must be true, so that R implies S is true. So there's still no violation. The first premise is still true. Now, false or true will be true. We're done. So we're done with the premises. We have shown that the premises are true. Okay. So we're sticking with these values. P, false. R, true. S, true. Q, either true or false. Now, we want to go to the conclusion. We want to show that the conclusion is also true. So far, what have we utilized? We're using, what's the conclusion? Q or S. For Q or S to be true, one proposition here must be true. And clearly, since S here is true, then Q or S will be true. So regardless of Q is 0 or 1, still Q or S will be true. Therefore, it's a valid argument. So, in our case, in our explanation, we have utilized P is 0, R is 1, S is 1, Q is 0. And our argument is a valid argument. Next, the last one, we have the destructive dilemma. It's very similar to number 8. We have the destructive dilemma. Same explanation. But let's go over. For the destructive dilemma, we have P implies Q and R implies S, not Q or not S. Those are the premises. The conclusion, not P or not R. So we want to explain that our argument is a valid argument. We have 4 propositions, P, Q, R, and S. We have P implies Q and R implies S. We have not Q or not S. And then the conclusion, not P or not R. Again, we want to show that the argument is valid. And to show that the argument is valid, the premises must be true, the conclusion must be true. So we need to find possible truth values for P, Q, R, S to make each premise to be true and the conclusion is true. Okay, where do we start? Again, for this entire proposition, P implies Q and R implies S to be true. We want this to be true. Then P implies Q must be true. R implies S must be true. For P implies Q and R implies S to be true, since this is a conjunction, then P implies Q must be true. R implies S to be true. Okay. For P implies Q to be true, we can use P is false. Because if P is false, automatically P implies Q is true. So it means Q can be true, Q can be false. R implies S is true. R implies S is true. We can use R is false. S can be true or false. So if P is false, this is true. If R is false, R implies S is true. Therefore, P implies Q and R implies S is true. Therefore, we have shown that it is possible that this is true. Next, we must also show that this premise is true. Not Q or not S. This is the connective OR. And for this to be true, we just need one proposition to be true. So remember, not Q or not S. So far, we have set P is false, Q is false. And Q can be true, Q can be false. S can be true, S can be false. But this is OR. Okay. So, if I set, let's say, Q is 0. If Q is 0, not Q is 1. Not Q is true. Diba? If Q is false, not Q is true. So regardless of S, this is true. Therefore, we have shown that the second premise is also true. Okay, how about the conclusion? Okay, for the conclusion, clearly, this will be true. Why? Since this is again a disjunction OR, so we just need one proposition here to be true to make the entire proposition true. But we're using P is false. If P is false, not P is true. So automatically this is true. Okay, so regardless of R, that will be true. Therefore, the argument is also a valid argument. So there you go, the 9 rules of inference. So let's look at some examples. I don't know how many examples we can discuss today, but just for our discussion, application of this, para hindi naman mabitin yung ating discussion. Okay, as we will now be using our rules of inference in our examples, actually, we will now combine our rules of inference and the rules of replacement to prove our statements. Okay, and this will be one example. Example number 1. Given. Okay, given. Not A implies C and D. And then we have A implies B, and then not B, and let's draw the conclusion, therefore C. So we have premise number 1, premise number 2, premise number 3. Okay, so what we will do now is, based from the premises, we want to arrive at our conclusion. So we will not show that this is a valid argument. We will assume that this is a valid argument already, and our goal is, based from the premises given, we would like to arrive at the conclusion. And how do we do that? We now use our rules of inference. In some lines, we can also integrate the use of the rules of replacement. So how do we do that? So look at your premises. So when proving an argument like this, you must be observant with your premises and then your conclusion. So your conclusion, we only have C. Since these are our propositions A, B, C, and D, we want to arrive at the conclusion C, so it means we want to get rid of our propositions A, B, and D in our premises. Therefore, what can we do first? Okay, look at premise number 2 and 3. So if we will use premise 2 and 3 together, looking at your list, we can use modus tollens. Look at modus tollens. Anong sabi sa modus tollens? If you are given P implies Q, not Q, therefore right? And isn't it that premise number 2 and premise number 3 is an exact representation of our modus tollens? P implies Q, not Q, therefore P. So we now add that as our new premise. Using modus tollens, this will now be, okay, sorry, this must be not P. That's modus tollens. A implies B, not P, therefore not A. What's the reason there? We have used modus tollens of line number 2 and line number 3, or premise number 2, premise number 3. So we get not A. Next, not A. So these are the premises that we now have, 1, 2, 3, and 4. Next, what can we do? We have a not A here, not A. And this is an implication. What can we use? Look at, in your list, where can you find implication? You can have modus ponens. And according to modus ponens, you have P implies Q, P, therefore Q. That's modus ponens. P implies Q, P, therefore Q. Isn't it that it's a replica of modus ponens? Line number 1, P implies Q. And then use number 4, P. P implies Q, P. So what will be our conclusion? Q. What's the Q? C and D. C and D. So that will now be number 5. We have C and D. Using modus ponens of line number 1 and line number 4. Modus ponens. We're almost there. We have already removed A and B in the picture. Our conclusion is C. But this is a conjunction end. Going again to your list, where can you find a premise using end? Look at simplification. Isn't it, for the simplification, you are given there P and Q, therefore P. So we can remove already the D there. This will only leave us C. Using simplification of line number 5. And after simplifying line number 5, we already have the conclusion. So we have proven our argument. Given these premises, therefore, this is our conclusion. Diba? Parang sa buhay lang yan. You will hear different stories. Those are your premises. So what will be your conclusion from those stories? So you have to verify. Based from their stories, tama ba yung conclusion na binigay? And we now have this example. Example number 1. Next. Today. And let's have, let me check a good example here. Let's consider this second example. Given, where's that? Premise number 1, not A or B implies C. That's premise number 1. And then premise number 2. We have Let me just clear the screen first. Let me change that. So next example. Let me just fix the labelings. We have premise number 1, not A or B implies C. And then second premise, not A. Third premise, not C. Conclusion, therefore B. So there you have it. That's the entire problem. Not A or B implies C. Premise number 2, not A. Premise number 3, not C. Conclusion is B. Again, like what I have used as an illustration earlier. You hear of different stories. Based from the stories, do I get the correct conclusion? So I have to verify. So based from the stories, do I have the correct conclusion? And where can we begin with our solution? Our conclusion is B. Therefore, we must get rid of A and B in our premises. So in proving an argument, we don't touch the conclusion naturally. We first consider, we work around with the premises. Okay? And here, what can we do? So we have not A or B implies C, and then not A, not C. Since we have here C, but we have here not C, in our list, what can we use? Look at modus tollens again. Again, for your modus tollens, you have P implies Q, and then not Q, therefore not P. Okay? Therefore, using modus tollens, we now obtain our fourth premise. Look at this. You have P implies Q, not Q. What's the conclusion? Not P. Not A or B. So that's just A or B. Modus tollens. That's modus tollens of premise number 1 and premise number 3. Okay, so we have already removed C from the picture. Our conclusion is B. We just need to remove A. And how do we remove A? We can use the other premises. So we have A or B is a new premise. We want to just have B. But we have here not A. We have here not A. Where can we find a format similar to that in our list? Look at this. A or B. So in your list, look at, do we have a formula that states P or Q there? Look at your disjunctive syllogism. In your list for the disjunctive syllogism, it states there that if you have P or Q, P or Q, disjunctive syllogism, we have P or Q, and then if you have not P, your conclusion is not Q. Okay, let's have a disjunctive syllogism. Sorry, this should be Q only. Go to your disjunctive syllogism. Number 6. P or Q, not P, therefore Q. Therefore Q. And use now premise number 4, premise number 2. Exact replica of your disjunctive syllogism. P or Q, not P. What's our conclusion? Therefore Q. therefore B, which is what we desire. So using disjunctive syllogism of line number 4 and line number 2. So there you have it for this example. Okay. Oops. Not A or B implies C, not A, not C, therefore B. So you can just go over again the explanation. I'll be giving another video lecture very soon. I'll be giving more examples. So for the meantime, we will stop here so that the lecture will not be that long. So for today, we have finished the explanation why the rules of inference are valid arguments, and we have shown 2 examples. So again, good day. See you again in our next lecture.